We see what I just mentioned. We are working on parts 1 and 2 today. We have this part 0 homework, which is a little bit weird. So I'm going to talk about that in my notes today. Other things worth mentioning. Tomorrow is a wellness day, so we do not have any classes tomorrow. And Friday has some odd assignments due. So just be aware of those. One is just like a check-in, so you just fill out these questions really quick. They're pretty straightforward, nothing computational there. And then 2, our second discussion is starting. So let's start by looking at the materials for Module 4. And then we're going to go over some notes to help you get started on parts 1 and 2, and technically 0 as well. Okay, so this module is titled Personal Income Taxes. And essentially what our goal is here is to create a calculator in Excel where you can type in any amount of income for the year, and your calculator is going to go through a couple different steps. 2 main ones though, primarily computing something that's called taxable income, and then dealing with the tax brackets that exist in our tax system that we have. So this first page has actually quite a bit of useful information that you need for part 1 and the rest of the parts, but I'm going to go through that in my notes in a second. Today, we're working on part 1, which is about hypothetical tax code 1, and maybe starting part 2, which is about hypothetical tax code 2. If we look at the spreadsheet has 3 tabs. This is primarily where we're working today. This initial tab has some of the initial information we need to compute how much taxes we owe. As we move forward through the module, the hypothetical tax code 2, we start introducing more tax brackets. And then finally, at the end of the module, we get this sort of a beast calculator we're going to make that has to deal with all of these tax brackets. And so we're going to take at least 2 days sort of to work this one out. That's probably one of the more difficult calculators that we've had to build so far. Okay, so now I'm going to move over to my notes that I emailed just about like 10 minutes or so ago and talk about some things in here. So the first thing I want to talk about is something called piecewise defined functions. And this is actually the content in part 0. So part 0 is all about the piecewise defined functions. And if you've seen them before, great. If you haven't, I just wanted to do like a quick example to explain what they mean. So typically when you see a regular function, it looks something like this. You have the name of the function on the left. So this is a function called f. And then you have the definition of the function on the right, which is x squared. And so if you're computing something like f of 3, you're just plugging 3 in for all your x's. And so f of 3 in this example is 3 squared, which is 9. Pretty straightforward. But a piecewise defined function looks a little bit different. Instead of having one little definition over on the right, we have 2 or maybe more definitions. And then next to those expressions, we have little inequalities that help us figure out which one we're using. So for example, if I do the exact same thing, compute f of 3, how do I know which expression to use? Well, you just look at these little inequalities off to the side and say, if x is bigger than or equal to 2, do this one. If x is less than 2, do this one. And so like in this case, 3 is clearly bigger than 2, so we're going to use the top one. So we plug it into x squared and we get 9 again, just like the top example. But if we have an example like this, where we want to compute f of 1, 1 is clearly less than 2. We plug it in to the second definition and we get that guy. So the value for x that you're plugging in tells you which of the 2 expressions you're using. And then you just plug it in like normal and you get a single number out. You never plug it into both and get 2 numbers. You always just get 1 number out in each case. So these functions are really useful in general, but why we are talking about them here is because the way taxes are defined, or computed rather, they're dependent on how much money you make. And so we have this giant set of like if statements, where it's like, if you make an amount of money between 10,000 and 20,000, you pay taxes in this way. And if you make between 20,000 and 40,000, you pay taxes this way, and so on and so forth. There's this huge list of definitions based on how much money you make. And that is what we are trying to do in this module. So let's go to the next tab, which talks about something called taxable income. This is the primary idea in part one. So let's see what's going on. Let's say we earn $100,000 and we're all single with no kids, so our taxes are all the same. And we want to figure out how much taxes we owe to the government. Well, you do not pay taxes on this entire amount. First, you get to take what's called a deduction, and we're going to take what's known as the standard deduction that everyone is allowed to take of $12,400. There is an alternative way, but we're not going to use that. Most years, you also get to take an exemption, which is why it's still in our calculator, but this got changed recently to $0, but we left it in there. You can sort of ignore it for now. And we add these two things together. So 12,400 plus 0 is still 12,400. That is the amount that is completely untaxed, and you get a keep. It goes straight into your pocket. And then the rest of your income is taxed at some rate. In part one, all of that's going to be taxed at 25%. So if we make like a little picture describing this situation, so here's my little bar representing all $100,000. This first chunk of $12,400, that's removed, so to speak, from because of exemptions and deductions. That's not taxed at all. And then all of this remaining amount is going to be taxed at 25%, at least in part one. So how do we figure out our taxes? Well, we have to figure out how much money is in this red area. So we take 100,000 minus this initial 12,400, multiply it by 25%. There's our tax bill. Now, the only sort of other situation we have to be worried about is what if you make less than 12,400? So all your income would be over here. You wouldn't have any in this red area, and you wouldn't pay any taxes at all. That's the other situation, at least in part one. So doing this by hand is not too bad, at least at first, because there's only two cases. So let's see how this looks. So in this first case, we got $100,000. The spreadsheet is going to tell you this amount. You don't have to memorize it or anything. So all we need to do, at least to figure out taxable income, is take this 100,000 minus the 12,400, and there's our taxable income. And then to get taxes, we would do another computation underneath or somewhere else where we multiply that by 25% and we're done. Now the problem is what happens in that other case? What happens if we only make $5,000? So I type in $5,000, I do the subtraction, and we just got a negative number. If you take $12,000 away from 5,000, we just got a negative. This doesn't make any sense. We need to come up with a way to have a formula here that sometimes does subtraction, but other times does something else. Well, in this case, this should just say 0, right? We don't have any taxable income if I only make $5,000. So how do we do that? Now we're going to introduce first new function in module 4, and it's called the if function. There are 3 things we have to plug in. The first of which is a logical test, like an equation or an inequality. It describes the scenario where you use one set of rules versus another. So like in the last example, this is based on, do you make more than $12,000 or not? Then you tell it, okay, what do you do if that thing is true? And you tell it, what do you do if that thing is false? So here's a easier example than the one you're going to do, but let's see how this works. Let's say you have some internet plan from Comcast that charges using the following rates. If your data is less than or equal to 1,000 gigabytes in a month, you just pay a flat $100, no matter what. However, if you start going over 1,000 gigabytes, you're going to start owing 20 cents for every gigabyte that entire month. So how does this work? Well, in the if statement, we start with some input cell. You always have some number, right, where you can change, you know, do I use 500 gigabytes or 600 or whatever. So we have this cell. And your logical test is going to reference that input cell. So in my example, that's E22. What I'm going to say is if E22 is less than or equal to 1,000, that's the first case. Then how much is my bill? That's the value if this blue thing is true. Well, my bill is just going to be $100. So that would be what goes in the middle section of my if statement. On the other hand, if this blue inequality is false, meaning I've used more than 1,000 gigabytes, that is how I would calculate my bill. I would take 20 cents times every single one of these gigabytes up here. So I've plugged it in like so. Let's see how it works. If it's 500, if it's 800, still 100, 900, 1,000, still $100. But once I pop over that 1,000, my if statement is smart and sees that, oh, this blue inequality is no longer true. I better hit it with that third part over here, and it calculates the bill in a slightly different way. This is exactly what we want to do in this module. We want a single function that can do one of two things. Okay, so I'm going to get you started in part one, because this is what you need to translate into an if statement to get started. If your your total income is less than or equal to 12,400, then your taxable income is 0. You aren't going to have to pay any taxes. On the other hand, if it's not less than or equal to 12,400, then your taxable income is going to be computed by taking your total income minus 12,400. And that's going to allow you to type an if statement here that does one of those two things. Either it's 0, or you can subtract these two things. And that's how you're going to start part one today. So try that. If you get stuck, I can help you out. But essentially, you are translating this sentence into a code that looks like that guy up there. Now, if, you don't necessarily have to, but if you get to part two today, it gets a little bit more complicated. Starts introducing the idea of tax brackets. So instead of just multiplying all your taxes by 25%, what actually happens is the more money you make, the higher this percentage becomes. And I want to look at least one example right here, because it's not as simple as just picking one percentage and then multiplying it by all your taxable income. You actually use both. And here's how it works. Let's say we're in part two, and the spreadsheet is going to give you this information here. The first $25,000 is always taxed at 18%, and everything above 25,000 to infinity, I suppose, is going to be taxed at 27%. So if we have $100,000 again, the first $25,000 in this sort of red area, that is going to get taxed at 18%, and all the rest of your money is going to get taxed at 27%. So now when you compute your tax bill, it's a little bit more complicated. It's going to look like this. First 25,000 times 18% plus all the rest times 27%. Add those together, there's your bill. You actually use both percentages here. Now, this is really annoying because it introduces another case that we have to worry about. What if you don't even make $25,000 in taxable income? What if the situation looks like this, where you only make $32,400? So this red area is not even going to be full, and we don't even move into this green area. Well, in that case, all of this amount is going to be taxed at 18%, and you don't have any of your income that's taxed at 27%. And so now your calculation looks like this. It's just all of your taxable income, 20,000 in this case, because if you take 32,000 minus 12,000, you get 20,000 left over. All of it gets hit by 18%. Multiply those together, there's your bill. Okay, so this is even more annoying because now we have to have an if statement that figures out, do you even make 12,000 from before? Then we have another if statement that says, do you go past this 37,400 number? So on and so forth. So what we're going to do is break our calculator up into steps. And this is simply one way you could proceed. When you get to part 2, the spreadsheet will give you this part. Now, it won't fill in this formula for you in blue, but you're going to use the exact same one from part 1. So assume you know all this stuff here. So what you want to do in your calculator, if we kind of go back to these pictures for a second, the hard part of these pictures when we're figuring out these computations is figuring out how much of your money is in the sort of red bracket and how much of your money is in the green bracket. So what we can do is add a column to our calculator. We can say, this is the amount of our taxable income in each row or bracket. And so we're going to look at this amount of taxable income here and try to split it up into piles and put as much as we can here. You know, this is the first 25,000, and then all the rest here. So that is going to require one more if statement to figure out how much of our taxable income can fit in this first row. And then you don't even need an if statement for the last number. All the rest of it goes there. And then it's really easy to finish. You just multiply each percent by the corresponding amount it's next to, add them up, and you're done. This is the hard part, trying to split up your taxable income into 2 separate piles. You got the 18% pile and the 27% pile. And it requires one more if statement when compared to part 1. So that's the main idea in part 2, if you make it there today. The last thing I want to talk about is an extremely useful tool in Excel, something called a data table. And here's the idea. Let's say we have this really complicated calculator. This is the calculator from last module. I just copied it in here, where you type in a date and cash, and you have to look up the close price, compute shares, compute spent, find these adjusted closes, compute the percent change, and then finally you can get the final value. This is a really big calculator we made. There's like 10 steps involved. Well, what if there was a question that wanted you to figure out this yellow number for all of these dates? Maybe you're graphing it. Maybe you just want to know the value. Well, there's a couple ways you could do that. I could go up to my calculator. I could type in one at a time this number. I could put that guy next to 6297. Then I could plug in the next one. I could put that guy next to here, so on and so forth. As you can imagine, this is going to be horribly annoying. If there's hundreds of these, it's going to take you all day. So we don't want to do that. You could put a single formula here that you can drag down. That is also extremely hard, right? You'd have to put all 10 steps in this cell before you drag it. Alternatively, we're going to use a data table. It does the exact same thing as those other two, but it's much faster. And so I'm going to follow these steps over here and show you how this works. Step 1, build a calculator. So we're done. We have this calculator from the previous module. Step 2, we're going to create a table, just like you're making a graph, where the left column has all these things I want to plug into my calculator, and the right column has space for where the answer is going to go that, you know, normally the calculator would figure out, but I don't want to have to do this manually. Now here's something that's a little bit weird, but you have to leave this top left cell blank. That's step 3. And then step 4, at the top of the second column, all you're going to do, we're essentially teaching Excel how to use our calculator. You're going to type equals and click on where the answer lives. So Excel knows where to find the answer. Okay. Step 5, we're going to go back to this blank cell and then highlight the entire table. Step 6, data tab at the top. Step 7, look for this button, what if analysis. If your button's are really small, it has a little question mark on it instead of the word. Click that. Finally, click data table. And we have one more thing. We already taught Excel where to find the answer, but we have not told it where to plug these things in. That's the last step. Also, notice how I have a column of stuff I want to plug in. So I'm going to skip this row box. I'm going to go down to this column box. And the last step is simply click on where you would normally type these values in. So I'm going to type all these dates into there. We hit OK. And there we go. Excel just did all of that for for us. It plugged every single one of those dates in and got the exact answer. I didn't have to copy them down one at a time. Couple weird things. You cannot delete one cell at a time. It won't let you. But if you want to get rid of this, just delete the whole thing at once and it'll go away. Also, I believe that very last step, this guy has to live on the same tab as this guy. Otherwise, it gets a little bit mad. But those are the only sort of two annoyances. Other than that, it saves a lot of time when you're plugging something in to a calculator that you spent, a half an hour on. So you don't have to go back and repeat yourself. You already have the calculator. Now you're essentially teaching Excel how to use it.